Now we're going to look at adding or subtracting vectors in 2 dimensions using components. So if I want to subtract 2 vectors, I'm looking for the difference. So how do I indicate that? Well, remember difference is delta. So the change in speed, and this is as a vector, is equal to the final speed minus the initial speed. So how do we show that with vectors? Well, we can show it graphically, and that's where we'll start. We'll start with a graphic representation. We'll go v2 minus v1. Now, this is v1, so we want to add negative v1. So what do? We basically change the direction it's pointing. So what do we have now? We have v2 minus v1, and we can show what the resultant is, and we'll show the resultant in red just to make it stand out. So here we go, resultant. So what is that one? That's delta V. So let's write that down, delta V. Now, that's all fine and dandy to be able to just sketch that out. But what do we do to find this? Because none of these is along a cardinal direction. What we need to do first is to break these into components. So I'm going to start with V2 and I'm going to break it into components. And you'll see what I'm talking about. So here's V2. Let's look at the components of V2. Now before we do anything else, let's define what direction north is. Let's put north right here. And let's put an N to show that it's north. Now there's no ambiguity. Or, instead of north, I have an even better idea. Let's use that as Y. And we use this one as X. It doesn't really matter at this point, as long as you're clear on which is which. So in this case, they have Y, and we'll define X this way. So what does that tell you? That tells you Y is up, X is to the right, minus X is to the left, minus Y is down. So let's put the components in on here. And I'll use a convention where I use a different color for the components just to make it obvious for you what's going on. So there's the Y component of V2, and here's the X component of V2. And as we said before, if we add these two together, we will get V2. So this one here, is called V2Y, and this one here will be V2X. And these are still vectors, so we'll summarize them that way. We'll make sure that we have our indication that they're vectors by putting the vector sign on them. Now, what I'd also like to include is the arrow. So let me just group those together, and I'll do the same with this one. And we'll use that in a moment. I'll show you. So group. Okay, that's V2. Now let's look at V1. Let's bring V1 down, and let's find the components of V1. Just like we did with V2. So this will be V2X, and this will be V2Y. So let's write that in. V1Y, V1X, and I'm going to group them, I'm going to group them together just to make it easier to show you what's going on. Group. Group those together. Group those together. Okay, now what we want to do with this is we want to take the y components and subtract from them the y components over here. And then we take the x components and subtract the x components of v1 because it's v2 minus v1. So to do that, I usually make some sort of table. I'm going to show you graphically. We're going to do it with numbers in a moment, but I'm going to do it graphically now because it's a lot easier to understand what's going on graphically initially. So I've made a table, and I want to start putting this stuff together. I'm going to remind myself that I'm subtracting. So my operations will go here. These will be I'm in the habit of always putting my x components first, my y components second. So what operation am I doing? I'm doing subtraction. And so consequently, what goes first is going to be v2, v2 minus v1. This is what I'm doing. It's the result of that is going to be, or what we say, the difference is delta v, the change in velocity. Now make sure you indicate the sign of what you're doing. So let's start with v2. v2 are both positive. So what we're going to do is we take v2y, that goes here, v2x goes here. And those don't change sign. Now v1x we're going to put here. But what we need to remember is that since we're going to be subtracting them, it's going to flip around. So minus v1x. And the same with v1y. Since we're subtracting it, what does that mean? That means it changes direction. Okay, so since I changed the directions, what does that mean? That means that now I'm just going to add these. So v2x plus v1x, what does that look like? Let's copy. There's v2x and v1x. When I put them head to tail like this, what do I end up with? I'll end up with a resultant that looks like this. And if you're not sure about this, why that works, go back and look at some of the previous videos. And then here I have v2y plus v1y, and the resultant looks like this. So when I'm done, that isn't my final answer. What do I need to do? I need to put these two things together again. So how do I go about that? Well, here's the result of v1. Here's the result of v2. So we put them together and we draw our resultant. And I'm going to make it red because just like before, this should be the same as our big resultant earlier. Now let's compare that. I'm going to make a copy and drag it up and go compare that back with what we started with when we put these together before. It's the same thing. So what did I do? I took these two vectors, I took them apart into components in x and y. I subtracted the x from the x, v1x from v2x. I subtracted v1y from v2y. I put the resultant here. from the results, I put the results back together in terms of the components to find out what the resultant was. It looks complicated, but when in the next problem, when I show you this with numbers, you'll understand how this is a very powerful tool.